Hello friends, welcome to our channel HTLT Electrical and Electronics Engineering. Today here I am going to discuss about earthing system part 4. Let's start. Material related to earthings. There are three types of materials are required for earthings. One, earth electrode. Second, earthing conductor. Third, protective conductor. Again, earth electrodes are of five types. First one, plate electrode. Second, pipe electrodes. Third, rod electrodes. Fourth, strip conductor electrode. Fifth, chemical earthing electrodes. Okay, next. Plate earth electrode. Where there is high earth fault current or flows, there the plate electrode are used. Plate earthing electrode are of two types. First one, GI plate earthing. The size of the GI plate earthing is 600 mm into 600 mm into 6 mm. Second, copper plate earthing. The size of the plate earthing is 600 mm into 600 mm into 3 mm. They are to be buried in the ground with their face vertical and their top are not less than 2 meter below the ground level. The surrounding of the plate is filled with mixture of charcoal, salt and soil shown in figure 1. A GI pipe is to be provided from top of the plate shown in figure 1. The top of the pipe is provided funnel with wire mesh for watering the earth. The top of the pipe is housed in a masonry enclosure 400 mm into 400 mm into 300 millimeter. The earth resistance of the plate electrode is given by R is equal to rho by A into root pi by A, where A is the total area of the both sides of the plate in square centimeter, rho resistivity of soil, resistivity rho is equal to resistivity of soil in ohm meter. Okay, next. Here is a picture of plate electrode. Here it is the plate 600 mm by 600 mm, 600 mm by 600 mm, and method of GI plate earthing. Here is the charcoal and coke with salt. Charcoals is of 95 kg and salt is of 5 kg. Both are mixed and poured surrounding the plate. Here is a GI pipe and here funnel with wire mesh for pouring of water, and this is the brick masonry, and this is a CI cover hinged to CI frame. Okay, next. Pipe electrode 38 mm to 50 mm dia and 3 meter to 4.5 meter long galvanized iron pipes are used for this type of earthing shown in figure 2. The pipe is buried vertically in such a manner that the top part of the pipe will remain 0.25 meter below the ground level. There are 12 mm dia hole at a distance 15 cm shown in figure 2 on the body of the pipe for supplying water to the surrounding ground during the moment of pouring water through funnel. For good result, the surrounding of the pipe may be filled with charcoal and salt. Rod electrode. For this purpose, 13 mm to 32 mm dia and 1.22 meter to 3 meter long MS rods are used. Strip electrode 25 mm into 3 mm to 50 mm into 6 mm GI strips or 50 into 5 mm copper strips are used for strip conductor electrode. These conductors are buried at a depth 0.5 meter to 0.6 meter underground. The earth resistance of the pipe and rod electrode is given by R is equal to 100 into rho divided by 2 pi L into log E 4L by D. L is equal to length of rod or pipe electrode in centimeter. D is equal to diameter of rod or pipe in centimeter. Rho is equal to resistivity of soil in ohm meter. The earth resistance of strip electrode is given by R is equal to 100 into rho divided by 2 pi L log E 4L square by WT. L is equal to length of strip electrode in centimeter. Rho is equal to resistivity of soil in ohm meter. W is equal to depth of buried of strip conductor in centimeter. T is equal to thickness of strip. Okay, next. Here is the method of GI pipe earthing. It is the GI pipe. Here is the 12 mm hole at a distance of 15 centimeter. 40 mm dia GI pipe. Here is the reducer funnel, and is the machinery, brick machinery, uh, CI cover, hinged CI cover. Here is the charcoal salt mixture. Here charcoal is used of 60 kg and salt of 5 kg only. This is 4.5 meter. Okay, next. Here it is chemical earthing. Chemical earthing, where we use chemical powder, coal and salt material, soil. There are two types of powder are used for chemical earthing. First one, bentonite powder is a brown color powder. Second, carbon powder is a black color powder. Bentonite powder is used in dry place, and carbon powder is used in normal place. Used of chemical earthing. If we want to use chemical earthing instead of normal pipe earthing, we can use. But there are some places where only chemical earthing will be done. In the hilly area, chemical earthing will be done. To make a chemical earth pit, following methods are done. Make a earth pit 500 into 500 into 300 mm. It is millimeter. Make a 100 mm dia hole of 3.5 meter depth. Make 26 kg of mixture of chemical powder with water. Wait for 8 to 10 hours. Place the electrode centrally in the hole. Fill the chemical earth pit with chemical compounding and water absorption. There is difference between chemical earthing and normal earthing. Chemical earthing. First, in chemical earthing we use chemical powder. In normal earthing we use salt and coal. Use of chemical earthing is in stony or hilly areas mainly. Uses of normal earthing is normal places. Chemical earthing is maintenance free, and normal earthing it requires maintenance regularly, pouring water, salt water, etc. Ohmic value more or less fixed. Ohmic value fluctuates of normal earthing. Ohmic value fluctuates. Less area and space required. Area and space required more. Okay, next. Here is a picture of method of chemical earthing. Here is pipe in pipe technology. It is the outer pipe. It is the outer pipe, and this is the inner pipe. And the middle portion is filled with conductive crystalline mixture. The inner pipe diameter is 25 mm by 40 mm approximate, and outer pipe diameter, outer pipe, this is the outer pipe diameter 50 mm to 60 mm approx. This is the inspection box, CI cover, connecting terminal, ground level. The this is 300 mm, this is 3000 mm. Okay, next. Here, how the protective conductor, earthing conductor is connected to earth bar from earthing electrode to consumers electrical equipments metallic cover is shown in picture in the figure. It is for is consumers electrical equipments metallic cover and panel. One is earth bar. Second is protective conductor. This is protective conductor. Third is earthing conductor. And E is equal to earthing electrode. And this is the earthing bar. Earth bar. Generally, earth bar is a 50 into 6 mm to 75 into 10 mm GI strip or 50 into 5 mm copper strip fixed to vertical surface, just like wall, etc. The conductor from earth electrode are fixed to earthing bar with nut bolt is called earthing conductor. This is again the conductor from the consumer electrical installations metallic cover and fixed to earthing bar with nut bolt is called protective conductor. This is protective conductor. Shown in figure above, when testing is required, it is done by open the nut bolt. Up to 250 volt only one protective conductor required. More than 250 volt, two separate protective conductor required. If one is disabled, then disabled for any reason, then other remains active. Note, the distance between two adjacent electrodes will be minimum 3 meter, and from building foundation the distance of the electrode will be minimum 2 meter. Minimum size of protective conductor up to 16 square mm copper phase conductor. The protective conductor size will be same of phase conductor. For above 16 square mm to 35 square mm copper phase conductor, the protective conductor size will be minimum 16 square mm. For GI protective conductor, the size will be 2.5 times. Okay. Next. Size of earthing conductor. The size of earthing conductor size should be such that at the time of flow of earth fault current, the value of ampere density should not exceed a predetermined value. Here is the formula. I by S is equal to K into I by root T is the ampere per square mm current density. I is the fault current flowing through the protective gear in ampere. S is equal to conductor in size in square mm. T is equal to the time taken to disconnect the faulty section by protective gear, 1 second or 3 seconds. K is equal to factor taking account of the heat capacity of the conductor materials, initial and final temperature rise. Highest fault current density of bare conductor. This is the time 1 second and 3 second for copper. For 1 second 205 ampere per square mm, and this is 118 for ampere per square mm for 3 seconds, and for aluminium 127 ampere per square mm and 74 ampere per square mm, and for GI is equal to 80 ampere per square mm for 1 second, and 40 second 46 ampere per square mm. Highest fault current density for insulated conductor. Time 1 second and 3 second. Here is insulation PVC XLP copper 136, and this is 170, and this is 80 99. For aluminium PVC 90, XLP 113, uh, 53 65. For GI, for 1 second PVC 40 ampere per square mm, for XLP 63 ampere per square mm, and 28 ampere per square mm 3 second, and 36 ampere per square mm 3 second for XLP. Minimum size of earth conductor. Size of phase conductor S is equal to square mm. For S, when greater than 35 but less than 50, for copper 50 and aluminium 96, GI 150. Size of phase conductor S square mm, when S greater than 50 but less than 630, then copper 70, aluminium 120, and for GI 186 square mm. Okay, next. Here it is discussed about TT system. In TT earthing system, the protective earth connection for the consumer is provided by a local earth electrode. This is the local earth electrode. And supply neutral is earth only at neutral point of generator or transformer. Here is the point, neutral point. But no PE conductor is given with supply conductors. That is, no PE protective earth conductor is given in the supply conductor. This is TT system. Okay, next. This is TNS system. In TNS system, the neutral of the generator or transformer is earth. This is earth. A separate and independent neutral conductor and protective earth conductor are run. Separate neutral conductor, protective earth conductor is run with supply conductor. The protective earth conductor for the consumer is provided from the protective earth conductor. This is the protective earth conductor from the this protective earth conductor, and this is a neutral. This is TNS system. Okay, next. This is TNC system. In TNC system, generator or transformer neutral is earth, and only one conductor run instead of separate PE and separate neutral conductor run with supply conductors. The protective earth connection and neutral for the consumer is provided from the one common conductor shown above. This is a one common conductor. This is TNC system. Okay, next. This is IT system. In IT system, the generator or the transformer neutral is not earthed. No earthing. Completely insulated earthing. No earthing is there. In IT system, the generator or the transformer neutral is not earthed directly or by some impedance. The protective earth connection for the consumer is provided by a local earth electrode. This is a local earth electrode. This is IT system. Okay, next. This is TNCS system. In TNCS system, the neutral of the generator transformer is earth. The P and neutral are combined in one conductor at the start point. This is a combined conductor at the start point of the supply. Consumer P and neutral connections are taken from separate and independent neutral conductor and protective earth conductor. This is separate P conductor and separate neutral conductor. This is divided into two parts. This is called TNCS system. Okay, next. Here it is TNS system. The neutral of the generator or transformer is earth. Independent earth electrodes are provided for the consumer protective earthing connection and runs parallel with supply conductor shown in figure. Here is the independent earthing electrode and run parallel with the supply conductor, and the consumer P connection is taken from this conductor. Here is the neutral point is earth. Okay. Thank you for watching the video. If you think the video is useful to you, please subscribe our channel and share it to your friends. Okay, bye. See you in the next part 5. Bye. Thank you.